All right, students, let's take a look at Lecture 7 problem set, and we'll go over the answers and walk you through how to solve these problems. All right, so number 1, consider carbon-13, an isotope used in a technology called carbon dating to determine the age of archaeological artifacts. Okay, so that last bit was just to tell you a little bit about carbon-13, but this problem really is for you to understand what an isotope is and different qualities of an isotope or quantities that you should know in an isotope. All right, so we refresh your memory that an isotope is basically an element that has a different number of neutrons, right? If they have a different number of neutrons, they weigh, sorry. And if they have a different number of neutrons, then they weigh differently, right? So let's go over these questions. There's A, B, C, D, E. Okay, good. So A, how many protons does an atom of carbon-13 have? Okay, so remember how to answer this question. Let's go to the periodic table. How do you know the number of protons something has? All right, so this is carbon. How do we know the number of protons? Well, it's the atomic number, right? So in this case, it is 6. Okay, so it has 6 protons. B, how many electrons does an atom of carbon-13 have? Remember in this chapter, we're still looking at neutral atoms. And in a neutral atom, the number of proton is equal to the number of electrons, right? Okay, I'm going to use a different color. This is weird. Okay, so how many electrons does it have? It would have 6. Okay, C. What is the mass in AMU of carbon-13? Well, remember that stating the fact that it's a carbon-13 means its mass number is 13. So therefore, the mass of carbon-13 is 13 AMU. D. How many neutrons does an atom of carbon-13 have? Remember again that 13 is the mass number. And then mass number is the number of protons plus the number of neutrons, right? So if that's 13, and we already know proton was 6 plus n. So we have to solve for n. Therefore, 13 minus 6 is equal to n. 13 minus 6 is 7, right? 7 plus 6 is 13. E, the atomic mass, okay, that's a different word here. Atomic mass of carbon listed on the periodic table is 12.01 AMU. Explain the difference between mass number and atomic mass. Great. So this is a key concept to understand, the difference between a mass number and the atomic mass. Remember we just said the mass number was this. The mass number is a proton number plus a neutron of an isotope. So you have different masses for different isotopes, right? Whereas the atomic mass is the average of all those masses with respect to the percentage of their occurrence. Okay, so for example, carbon has carbon-12, carbon-13, carbon-14, right? So there are different carbons. Some carbons are 12 AMU, some carbons are 13 AMUs, and some carbons are 14 AMUs. They have different masses. But if you average them all, they come out to be 12.01 AMU. Right? Well, what does that tell us about the abundance of carbon on Earth or in the universe, as for that matter? Well, if the average was 12.01 is basically 12, right? So that tells you that most carbons are actually carbon-12. Right? Because if you average them all, if they were equal parts, then you would say the average would have been 13, right? But it's not 13, it's actually 12. That means most carbons are actually 12, the isotope carbon-12. Okay, so that's a little bit distinction between the mass number and the atomic number. So go ahead and fill out this table now to really to really see if you understand how to count protons and neutrons and what the mass number versus what the atomic mass of an element is. So the first column says carbon, and the number on top is 14, and the number on bottom is 6. Remember, the number on bottom is just the atomic number, which is redundant because carbon is always going to be 6. So sometimes we write this as basically carbon 14 like this, or sometimes we write it as carbon dash 14. We don't really need that 6. But I just put it there just to let you know that these are the 3 ways that you will be seeing the isotope. All right. So atomic number, this is 6, as we have seen from here, and also from the fact that it's a carbon. How many protons? Well, atomic number is proton number. How many neutrons? Okay, so neutrons is 14 is a mass, minus 6 equals 8. Okay, so that's 8, 8 neutrons. What's the mass number? We just found out the mass number was 14. The atomic mass, so how do we find the atomic mass? Remember, the atomic mass is in the periodic table. So let's zoom in to the periodic table. And here the periodic table says it's 12.0107. So in this class, we always round to the hundreds in the periodic table just to make things easier for ourselves. So we just write that as 12.01. Okay? So that's 12.01. The AMU, the unit here is AMU for all of them. Great. All right, so let's do the second isotope here. It has an atomic number of 29. Okay, I'm going to zoom out again. So we go to atomic number 29 is copper. Okay. Okay, so we know that copper, since we're down here already, let's say it says 23.55, 63.55. Right, so that's 63.55 for its atomic mass. And we already know that was copper. Okay, so number of protons is the same as the atomic number, so that's 29. Number of neutrons is 34, that's given to us, and the mass number is the protons plus the neutrons. So let's do the math. 9 plus 4 is 3, 3 plus 2 is 5, plus 1 more is 63. So this is copper, 63. Great. Okay, so let's see if we can do this on your own. Go ahead and pause the video if you want to try it on your own, and then replay it when you want to see the answer. Okay, so this one, protons is 9. That means its atomic number is 9. From the periodic table, we see that that's a fluorine. And fluorine has atomic mass of 19.00 AMU. We know that its mass number is 19, so therefore 19 minus 9 is your neutrons. Okay, so how do we write this isotope? We write F19, dash 19. Good. Next, we know this is a proton number of 30. That means its, again, atomic number is 30. So go to periodic table. 30 is zinc, Zn. And zinc has a mass of 65.41. What else do we need? We need the mass number. Mass number is 30 plus 34, so that's 64. So this is zinc, 64. Great. All right. Let's continue. Page 2. So in this lecture, we also learn about electrons and where they reside. In an atom, there are different levels, right? In the first level, you can get 2 electrons. In the second level, you can get a maximum, you can put a maximum of 8 electrons, right? So let's give you that example here. And then third level, another 8. So every level after that is basically 8. At least in this class, that's what we'll learn. It gets more complicated than that, but we don't need to know beyond that. Okay, so your job is basically to see how many electrons an atom has, and then therefore house those electrons in different levels. This is the first level. All right, this is the second level. This is the third level. And, and in this class, we only have to go up to calcium. So, so chlorine. How many electrons does chlorine have? So let's review. Chlorine's right there. It has how many electrons? 17 electrons, right? Okay, so let's put 17 electrons in. Well, let's count the number of electrons. If I were to have 17 electrons, how many is that? Where would I put them? So the first 2 in the first shell. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Notice that I will only go up to the third shell to answer this question. Okay, so how do I write that? Well, remember I said I have the first 2 is in the first shell, so I say 2. Then I filled up that shell, so I moved to the second shell where I have 8, right? So I filled up that shell with 8. And finally, I filled up the third shell with 7 more to give me a total of 17. So that's called 2, 8, 7.